Does the mic work? Yes, okay. So before I start, I want to explain why I have two microphones. One of them is going to control my computer. So I'm going to try to control the slideshow only using my voice. So this may fail horribly. I don't know what can go wrong. And if it does, that's just going to be fun. Go next. Go next. So anyways, this is maybe the first talk of this quote-unquote decade. People are not in agreement if it's a new decade or not. Some people say it's next year, I don't know. To me, 2020 is like a new decade, so maybe the first talk. And I'm going to be talking about X state, but more generally, I'm going to be talking about state charts. Just by show of hands, does anyone here know what state charts is? Like 4 people. Okay, does anyone know what a state machine is? Okay, most people. And when I say state, often what comes to mind is something like React state, this.set state, and so on. Go next. But we are going to define state as a qualitative mode or status of a system. Go next. So this means it's not a data store. It has nothing to do with keeping the track of, the age or name of a person or I don't know what to keep in the state. Has nothing to do with React state, nothing to do with a Vue state. It's just in what status are you at a given moment. Go next. Go next. And if we take an example, a car is either stopped or driving. We are now in the stopped state, so we cannot be driving. There's no way for us to be both stopped and driving at the same time. Go next. Go next. Sorry? Then you're not stopped though. Then you're sliding. Yeah. So when we go from one state to the other, it's called a state transition. And to make a state transition from one state to the other, in this case from stopped to driving, from driving to stopped, we dispatch events. Go next. So this is a state transition. And these 3 things, a state, a transition, and events, encapsulate a state machine or a finite state automata. Go next. Next slide. And this is like a definition of a state machine. It's basically an abstract machine that's always in a stable known state. And it's always determined by what state came before that or what state comes after that. So if you are stopped, you can't really stop again. You are just stopped. But you can't go into a driving state. And it's really easy to depict or demonstrate how a state machine works. Go next. By using a switch statement. So this is just a nested switch case statement, basically. The outermost statement is switching on the state. And the inner switch state is switching on the event. Go next. Go next. So if we visualize this, we are now in the stopped state. And this is like a hypothetical function, by the way. and we get in a new state, a new event. We are on the stop state. Go next. Go next. Go next. Next slide. There we go. And if we dispatch an event called drive, we will transition to the driving state. Next slide. And now we're in the driving state. And for that state, we have events that can stop the state to go back into the stopped state or status. So as you can see, if you are in one state, you cannot dispatch an event and do something unpredicted. You can't, start flying or something, because that's pretty easy with regular if statements. Go next. Go next. Go next. Here we go. And if you look at the switch statement again, it's only these 6 keywords that we're really using. We're only interested in the states and events. So we're going to use a library called xstate to simplify this for us, simplify the double switch state, switch case statement. Go next. Go next. Into this thing. Go next. And now we only have a small object that represents our entire state machine. This is the same state machine that we had earlier with the stop state and driving state. And we have events called drive and stop, which go to the corresponding states. Go next. But these kinds of state machines, if they grow, they're going to grow way too complex to be able to maintain. And go next. This is a state machine I found online. I have honestly no idea what it does, but it's super big and complicated, and it's not really easy to parse. And what a man called David Harald did in 1980 something, he created he published a paper on Statecharts, which will visualize the state machines in more complex systems. Go next. And David Harald did many things in this paper. He introduced many concepts to simplify complex applications and complex logic, and we're going to explore that a little bit now. Go next. Go next. But why should we learn another thing? And this is I feel like this is the JavaScript motto. Every year there's a new thing. There's also a new framework, new something. But the thing is that state machines and state charts are like 30 years old. They're old things. We're relearning how people used to do it. And NASA uses state machines to control the Mars rover and the Apollo space shuttles back in the day. So, I mean, they can't really, explode or stop driving because undefined is not a function. So, go next. We will have fewer bugs if we use state charts. There was research done that indicates that we have 80 to 90% less bugs if we use state charts. And the remaining bugs are bugs living outside of the state chart. So due to something else. Go next. We can reduce the mental effort of, us doing programming, because we can stop trying to understand complicated code and just visualize how the app should behave. Go next. This is a typical code example from a async function. Can anyone spot the bug? Gonna give you like 10 seconds. Just by raising hands, can anyone see a bug? 1. There are actually at least 4 bugs in this code. And the thing is, they're really hard to spot. For example, we never reset the state if we have an error. We never stop the timer if we have an error. The is taking too long thing that we have there never resets. So if we finish this function and we have that message go up, we will always have it, unless we run the app again or something. We restart the app. But this is really hard to understand, especially if you are doing a code review, if you are doing glancing code like we are doing right now. It's pretty hard. Go next. This is the same thing, but without bugs. This is the same example, and it's pretty clear what's going on. We have a state called searching. Within that state, we have a substate, which is instant. I didn't know what to call it, but after, that should have been 1,000 milliseconds, we show a message that says, the internet is slow or something. This is the same code as the code before, but just visually represented in a state machine, in a state chart. So yeah, go next. Go next. Another reason to learn state charts is to allow non-programmers to understand our code. Go next. It allows us to handle non-happy tough scenarios. It's quite often that we have applications that run perfectly well given the perfect conditions. But we never realize that the imperfect conditions can happen, and when they would happen, and how they would happen. But if we visualize our code, we can actually see it just by pointing and saying, hey, we're missing an arrow here. We're missing this state. We're missing an event. It allows QA teams to discover bugs and allows us to find errors more easily. Go next. Go next. And for us at Hop, we found that in code reviews, this helped quite a lot because when we have a complex logic change and a bunch, maybe like 1,000 lines of code that goes along with it, a simple image is going to help the reviewer quite a lot in understanding what's going on. Go next. So let's learn to code. Go next. Go next. I created a very simple app. Is it playing? I can't see it. Yeah. So this is basically a app to help me learn Chinese characters. It is basically just looking up character information, and it's a simple fetch request. And we can add it to a deck of flashcards that we can then look at later and study. But we are going to be focusing on the input we have, the lookup. Go next. So this input that we have, we type in the character and press search, it should have these requirements. This is our requirement list for that particular input. And we're going to build this using XState. And yeah, go next. So this is our state machine with collapsed states. We only have 3 states. We have the input, where we can type in the data, type in the characters. We have a searching state, which is kind of like a loading state, if you will, and we have like a detailed view. Go next. Earlier I said that we have state, and state is not data storage. However, XState allows us to store data in a thing called context. So context is our data storage, basically. The thing that we have access to within the state machine. And actions, they run side effects. So we can run different actions based on transitions, based on entering a state and leaving a state. In this input scenario, we have focus and unfocused states. These are for UI animations. I don't know if you saw it earlier, but the label, it goes up and down when you click it. Go next. And the searching state, this is basically the same thing that we saw earlier on the faulty code thingy. And as you can see, we can visualize the code and we can interact with it using the XState visualizer, which is online. It's pretty good and allows us to interact with our code and learn how it works. In addition to regular state transitions, we have delayed transitions, which will happen automatically after a given time. And this is really helpful. Go next. And the final state is the detailed state. This is the state where we show the character information, and yeah, it basically only has one event called clear, and that will just clear all data and take us back. And on exit, it runs an action called clear. And we also have on entry. Go next. Go next. So this is our final state machine for this entire component. I've added one thing there that I forgot to have in my code, and that's the search event. The search event has a condition. Is the green thing that you can see there is not empty, and that means that the transition only takes place if a condition is true, or yeah, true. So we can have a search event with many conditions that will go to the correct state depending on some previous condition. Go next. And we can visualize this and see it in the app. So as you can see, when you click on the input, it's going to animate the title, and you can see all of the states. And by the way, I didn't have time to create a post, so I just created a plain old alert. Hope that's fine. Yeah. Is the alert up yet? I can't see. Yeah. So that's basically all of the states of the state machine visualized. And this is basically the most basic, most useful features of Xstate and Statecharts, and that is to visualize your mode of status of your application. It allows you to create quite concise components in a JSON object format. You can share this component or this state tree with your React application, your Vue application, your server, I don't know, whatever, and it just works. Go next. However, I did not cover everything because this is a really dry subject. I realize that. It's just talking about this kind of makes me want to go to sleep. So, but it's really useful and it's awesome. The power is so good, but like it takes maybe a week to get familiar with everything. But once you are, it's so nice to work with state charts and state machines. I did not cover these topics. Parallel states, they are states that run at the same time. So in that case, you can be in the car, you can be driving and listening to a radio, or something. Driving and sleeping, maybe not, but Actors is just the actor model, mathematical model, where you can spawn and subscribe to what's it called? Children? I don't remember the word. Anyways, you can create new state machines, run them, send messages, and receive messages from them. We have history states. They are useful for knowing which state you came from when you go back into a state machine. So, you leave work on a Friday, you remember you were replying to an email, you come back on a Monday, you pick up the email where you left off. That's kind of what history states are. Persisting states, you can rehydrate your state machine from local storage or something else. Activities, they run during a time. So this is useful for subscribing to events or adding event listeners to an element because they live while the state exists. And implementation details, I did not cover those for a reason. There are so many different frameworks. We have Angular, we have React, we have Ember, Vue, and it doesn't really matter what you use because Xstate works the same amongst all of those. You just have different implementation details per framework. Go next. Go next. However, at Hop, and for those who don't know what Hop is a micro-mobility platform. It's the scooters that you can rent downtown and drive around Reykjavik. We created that platform, an app, using Xstate. And I just wanted to show you briefly a few real use cases of Xstate. Go next. This state machine is basically our polling. It takes care of updating the vehicles on the map. And it's pretty simple and it's really nice to work with because we can see what's going on and what can happen in every state. And if we want to fix or add a new feature or something, it's quite simple. Go next. Go next. And then this is the thing that controls the entire app. Go next. Go next. And just to zoom in, this is like a portion of it. And if you are writing a state chart or a state machine, this feature, zooming in, is the best because you can look at one part of the state chart, one part of your application in isolation. And I just know that when I start the app, I will be in the initialize state, and then I'll go into the inactive state. I just know that by looking at this. And there's no other way into the app. Yeah, go next. And that's basically all for my introduction to ActState, simplifying complex systems by introducing a new complex thing. Any questions? How would I introduce ActState into a big code base? We actually did this for Hop. You can do this on a per component level. So you could just introduce one new component using ActState. And then from there, add more components, more.
Out of batteries. Ignore me.
The third mic. This is awesome. Yeah, but you can add just to one component or one branch of your project pretty easily. So yeah, does that answer the question? Another question? Yeah. Yeah, so I forgot. Yes. What about dev tools? I forgot to mention that. This is fun. You have, it's fine. Yeah. There are dev tools. So the thing I showcased, where you can click around the state chart, that's called ActState Visualizer. That's kind of official. Other tools exist, and you can actually hook into the Redux dev tools. It works kind of, it's limited, but it kind of works. You can see how everything goes. And I've also seen dev tools extensions where you can visualize real time while the app runs how a state machine goes around business. It's kind of cool. Yeah. Anything else? Yes. Yes. Is the framework being actively contributed to? I think there was an update last week. So yeah, and it was like a new minor version with new features. And I think TypeScript support came 2 weeks ago. So yeah, pretty active. I have no idea how many contributors. No idea, but probably. Anything else? I have one question here that I wrote just for fun. Why not to use Statecharts? Because I didn't cover that. To answer my own question, I would not use Statecharts for hackathon projects. I would never use it for something that's super, you're supposed to deliver tomorrow, because at least while you're learning to use Statecharts and state machines, it is going to require a new way of thinking, and this takes time. But in turn, you get, better quality products. So yeah, trade-offs. All right. Anything else? Good. Thanks.